So assume we have our ring A, and as I have mentioned, we are assuming that A is a principal ideal domain. Every ideal is generated by a single element, and we are going to show that every prime ideal is maximal. So the proof is fairly easy. Let me show you. So suppose we have a prime ideal. Since we are working in a principal ideal domain, this prime ideal has to be generated by a single element, for instance x. So this is our prime ideal. It's generated by this element x. And suppose that it is contained in another ideal, which is also generated by a single element. So this ideal generated by x is properly included. So this is a proper inclusion in the ideal generated by some element y. Note that this implies that y is not an element of x, since otherwise this inclusion could not be proper. So y is not an element of x, and but y is in x is in the ideal generated by y. So there is a way to write x as a multiple of y, since this ideal generated by y is made up by the multiples of y. So we can write x as y times z for some ring element z. And now we have just said that y is not in the ideal generated by x. This means that z has to be in the ideal generated by x, since this product is in the ideal generated by x. It is x, and the ideal generated by x is prime. So by primeness, we have to conclude that z is an element of the ideal generated by x. So we can write the element z as x times t for some element t. But then we can look at this equation and write x as y times x times t. And this is a commutative ring, so this is the same as y times tx. And thus y times t is equal to 1. So this is equal to 1. And thus we see that y is a unit. Or in other words, the ideal generated by y is the ideal generated by 1. And thus there is no proper ideal containing the ideal generated by x. If we assume that there is one, then we have to conclude that this is the ideal generated by 1. And this concludes the proof. Thank you for watching.